We start off chapter 13 talking about allenes. Now, allenes are unique dienes in that they contain their two double bonds that share a common carbon. And if we think about what that looks like, in the simplest terms, we have to have three carbons. And so the simplest allene is called propadiene. And you notice that central carbon is sp hybridized, right, because it has two p orbitals to create those two pi bonds. And therefore, it's actually a linear geometry. Now, propadiene has a common name. It's called allene. This is where, in general, allenes get their name from that common name. And of course, we can draw different structures that show that linearity. So this is 2,3-pentadiene. Again, notice on the third carbon, that third carbon is sp hybridized, and so it's linear. So we draw it in a manner very similar to that of alkynes. And here we have 2-methyl 2,3-pentadiene. And just to kind of give you some visualization of what allenes look like. So let's explore the structure of allenes just a little bit closer and see the unique characteristics of them. If I take a look at and emphasize the three carbons that are creating the two double bonds, I've already said that central carbon is sp hybridized, but obviously the two carbons on the end are sp2 hybridized, and then in that middle is that sp hybridized carbon. So if we stop and think about really what geometrical ramifications this has, we can think about those three carbons, and of course they have a sigma bond that's connecting all three of them, and then they have a pi bond. So if I focus on the pi bond on the left-hand side between the carbon on the left and the central carbon, I know that pi bond is created by the p orbitals, and if I place those p orbitals in the plane of the board, so these p orbitals are in the plane of the board, and of course the pi bond is created from the overlap of those two p orbitals. Now, because the carbon on the left is sp2 hybridized, the geometry of it is going to be trigonal planar, and therefore any groups coming off of that carbon, one of the groups has to be coming out at us and the other group has to be going away from us, so giving us that trigonal planar geometry where the bond angle is 120 degrees. All right, so we can visualize what that looks like, very similar to your typical alkene. Now, that central carbon is sp hybridized. So what does that mean? It has another p orbital that's overlapping with a p orbital from the right-hand carbon. And so that p orbital has to be perpendicular to the p orbital that's overlapping with the left carbon. And so we get this juxtaposition where the two pi bonds are actually perpendicular to one another. The other result of this is that if there are any R groups coming off of that right carbon, those R groups have to be in the plane of the board, right? So they're 120 degrees from one another, but they are in the plane of the board. Now, what that means is that the R groups on the left are actually perpendicular to the R primed groups on the right. So what do allenes actually look like, and how do we draw them? Here I've drawn 1,3-dibromo 1,2-propadiene. And you notice that I have one of the bromines coming out at me. I could have the bromine going behind me as well, and we'll talk about that in just a little bit. And of course I have the bromine on the right drawn on the top, I could also have it drawn on the bottom. Here's a structure of, so this is 2-methyl 2,3-pentadiene. This is one of the structures that I drew in the previous slide. And you see that in this case, one methyl group's coming out at me, the other methyl group's going behind me. So if we think about stereochemistry of allenes, we see that there is a potential stereochemistry in that the structure on the left actually is chiral, because if I draw the mirror image of it, it is non-superimposable, and so it is a chiral molecule. Now, obviously, the allene on the right-hand side is achiral. There's a plane of symmetry throughout this molecule, but this is something that we have to think about when we're drawing allenes. Are they chiral, or do they have a plane of symmetry?